Okay, so we can also identify points in ordered pairs. So a coordinate plane is formed when the x-axis and the y-axis intersect at their 0 points. The axes separate the coordinate plane into 4 regions called quadrants. Okay. You can use the location on the plane or use the x-coordinate and y-coordinate to identify the quadrant in which a point is located. So let's take a look at some examples. So one says, identify the ordered pair that names point C, then identify the quadrant in which it's located. So the first thing I want to do is look at my graph and figure out where C is. Well, here's C right here. Okay, so then I want to figure out what the x-coordinate is. So I start at 0, and I go over until I get to my point, which is 1.5, and then I go up, and that's at 1. So I went over 1.5, and I went up 1. So step 1 is to go over to where my x-coordinate is, that's my x, and then up or down to where my y-coordinate is. So I have 1.5 and 1. This one's in quadrant 1. So point C is in quadrant 1. Both coordinates are positive, so that's why I also know it's in quadrant 1. Number 2 says identify the point located at -1.5, -1, then identify the quadrant in which it is located. So I can look back at my graph. It's at -1.5. So I go -1.5, which is right there, and then down -1. So the point is B, and this is located in quadrant 3 because both points are negative. I know it's in quadrant 3. So it's point B, and both coordinates are negative, so point B is in quadrant 3. Okay. We can also deal with reflection on the coordinate plane. You can use what you know about number lines and opposites to compare locations on the coordinate plane. Consider the number line and coordinate plane below. The number line shows that -4 and 4 are opposites, right? The coordinate plane shows that the points -4, 0 and 4, 0 are the same distance from the y-axis in opposite directions. So here's -4, 0, and here's +4, 0. So they are reflected across the y-axis. Notice that the y-coordinates did not change and that the x-coordinates are opposites. So example 3 says name the ordered pair that is a reflection of -3, 2 across the x-axis. So this is where I start, -3, 2, and this is my x-axis, so I'm reflecting across, so I get -3, -2. To reflect across the x-axis, I keep the same x-coordinate, so my x-coordinate stays the same, -3, and I take the opposite of the y-coordinate. So the opposite of 2 is -2. So -3, 2 reflected across the x-axis is located at -3, -2. Okay. 4, Kendall is building a square fence. She places the fence post at the locations indicated on the grid. What is the location of the point of the post that reflects -4, 4 across the y-axis? Okay, so here's my point. Right, I'm gonna go back up to this grid right here. -4, 4, So there's my point at negative 4, 4. Okay, and I'm reflecting across the y-axis. This is the y. Okay, so in order to do this, so I'm going this way, right? My x is my opposite now, and my y-coordinate stays the same. So to reflect across the y-axis, I keep the same y-coordinate. And the opposite x-coordinate. So it's the opposite. Opposite of negative 4 is 4. So my coordinate, so negative 4, 4 reflected across the y-axis is 4, 4. All right, so there are a couple of try-it problems. I want you to go ahead, pause the video, and when we are done, we will go over the answers together. All right, so now that you've had a chance to try out the try-it problems, let's go over the answers together. So letter A says, refer to example 1, identify the ordered pair that names point A, then identify the quadrant in which it is located. So we're going to go back to example 1. Okay, so here's my example number 1. And it said point A. Here's point A. So I'm going over negative 1 and up to 1 and a half. Okay. So for letter A, I went over negative 1 and up 1 and a half. Okay, so that's the first part. And then I have to figure out which quadrant it is. Well, I went over negative first, so that's going to be quadrant 2. Okay. Letter B says refer to example 1. Identify the point located on 1, negative 2. Then identify the quadrant in which it is located. So back to example 1. Told me 1. So go over to 1, which is right here. Then down to negative 2, which is point E. And E is located in 1, 2, 3, 4. The 4th quadrant. So letter B is point E, and it's in quadrant 4. Okay. Letter C says name the ordered pair that is a reflection of the point 1, negative 4 across the x-axis. Okay. So this means my x stays the same because I'm reflecting across the x. So that's 1. And my negative 4 is the opposite. My y-coordinate's the opposite. So the opposite of negative 4 is 4. So my coordinate is 1, 4. Letter D says name the ordered pair that is a reflection of the point negative 2, 5 across the x-axis. Okay, so again, x-axis, my x stays the same. My y changes. It's the opposite. So I get negative 2, negative 5. Letter E says name the ordered pair that is a reflection of the point negative 3, negative 1 across the x-axis. So again, I have x-axis, so that means my x stays the same, and my y is the opposite. So I have negative 3, 1. Letter F says name the ordered pair that is a reflection of the point -3, -1 across the y-axis. So now my x-axis, my x value changes, it's the opposite, and my y value stays the same. So I get 3, -1. Okay. Letter G says name the ordered pair that is a reflection of the point 1, -4 across the y-axis. So y-axis, my y value changes, my y value stays the same, and my x value changes. So 1 becomes -1, and -4 stays the same. Letter H, name the ordered pair that is a reflection of the point -2, 5 across the y-axis. Okay, so I go y-axis first, so y stays the same, x changes. So -2 becomes 2, and my y value stays the same. So I get 2, 5. Okay. Letter I says Kendall placed a fence post at -4, -4. What is the location of the post that reflects -4, -4 across the y-axis? So again, y-axis, my y-coordinate stays the same. My x-coordinate is the opposite, so the opposite of -4 is 4, and my y value stays the same. And that is the end of lesson 6.